This is a rocket motor that I made and tested for a rocket named Spring. After a few failed attempts and learning more about rocket motors, I finally made a motor that I feel really confident about. This video is part of a series where I'm building a rocket using very simple materials. So in today's video, I'm going to show you how I made this motor. And to make everything easier to understand, I'll also use a 3D model of the rocket motor. So let's start the video. In my old motor design, I used this PVC pipe that had a smaller diameter than the rocket's motor mount. The old design worked pretty well, but it left a lot of empty space in the motor mount, and it might have been underpowered too. So this time, I used a different pipe that fits perfectly inside the motor mount, and its wall thickness is much greater than the old one, so it should be able to handle pressure much better. This motor is going to be around 9.5 inches long, which means it can hold much more fuel. This time, I also decided not to make the nozzle and end cap separately, like I did in the old design. Instead, I'm building them directly into the motor body for a much cleaner look. At first, I started making the nozzle, and for that I only needed a 1-inch piece of PVC pipe. It wasn't fitting inside the motor body properly, so I cut a slot in it to help compress it slightly and fit it inside. I also needed 2 metal washers. The larger washer holds the smaller one, which has a 10mm hole in the center, and that will act as the throat diameter of the nozzle. The PVC piece fit very tightly inside the motor body, and it actually needs to be tight, otherwise it could fail under pressure. After that, I glued the small washer onto the larger washer, then glued the PVC piece inside the motor body. Finally, I dropped the glued washers into the motor and secured them in place using super glue. And that's it. Half of the nozzle was done. Can you guess what are you looking at? No, I don't think you are smart enough to guess. Well, I am not smart either because I had already completed the nozzle. And as you can see, it looks very good, but I somehow deleted the footage. So I can't show you how I made it. But I can still explain the process. If you look carefully, you'll see that I drilled some holes through the motor body and through that PVC piece. After that, I applied some clay adhesive or 2-part epoxy putty. It looks and feels like clay, but once it cures, it becomes rock hard. Then, I gave the nozzle its shape using a metal pipe and my small finger. While I was shaping it, the clay came out through all the holes I drilled, which should make the joint much stronger. I could have just used screws, but then the motor wouldn't fit properly inside the motor mount. I cut this 15mm diameter metal tube from a baby cart or baby stroller, whatever the correct name is. You get the point. I'm going to use this metal tube to make the core in the fuel grain. And this is a 33mm diameter cardboard tube with a wall thickness of 2mm. I'll use this as the liner inside the motor. My old motor didn't have any liner, but this time I decided to use one. So I thought I could make something that would help me pour fuel inside the motor. And I've seen other people doing something similar. I started by attaching a PVC piece to the coring rod. I cut a rectangle out of a PVC sheet and glued it onto the rod. After that, I applied some clay adhesive to give it a pointy shape. The rod was ready, but it still needed something to hold it perfectly in position. To do that, I cut a piece of cardboard tube that could fit onto the motor body. Then I glued everything together and ended up with this silly-looking thing. I'm pretty sure this thing will work. Honestly, it looks like the mouth of a turbojet. For some comrades, buying potassium nitrate is very difficult because of their motherland's rules. It's also not that easy to buy stuff like this in India, but a lot of people still manage to get it. This is 1 kilogram of potassium nitrate that I bought from a local market. It cost me 200 rupees, which is around 2.8 US dollars. I got it in crystal form, and while I was buying it, the seller asked me if I was buying it to feed buffaloes. I got confused at first, but then I realized that KNO3 is also used in buffalo feed. Does anyone know the reason for that? I already had around 130 grams of KNO3 powder left from the last video, so I decided to use it to make the fuel grain. At first, I made a 200-gram batch of rocket candy fuel with a 65-35 ratio. I only used normal sugar and didn't add anything extra. I was thinking about using corn syrup too, but I dropped that idea. I want to mention that I have done this kind of stuff many times before, and I know what I'm doing. If you're planning to make rocket fuel or a rocket motor by yourself, you should do it with someone who already has experience with it. Always keep safety at the top priority. Otherwise, making rocket motors might not stay fun anymore. Now let's start cooking. First, turn on the heat and put the mixture into the pan. Then add enough water to fully cover the mix. You just have to keep stirring it and keep the heat low. Around 150 degrees Celsius should be fine. You can definitely do this without water, but then you might burn the sugar, and the final fuel mix would become much harder to pack inside the motor. When you add water, you also have to make sure that all of it evaporates properly. Otherwise, the fuel will not perform very well. It is looking like when all the bubbling is gone, that means the fuel is ready to be packed inside the motor. I applied some oil on the coring rod and started pouring the fuel, but it was just a mess. Nothing went the way I expected. The fuel mix was too thick, so I wasn't able to pack it properly. Some of the fuel got inside the motor, but I took it back out. The whole plan of making that silly thing was stupid, and I honestly don't know how I thought it would work. After that failed casting attempt, I ended up wasting a lot of fuel. Now I'm going to do it in the simple and common way. First, I took the liner out of the motor and removed that PVC rectangle. Always wear protective gloves while working, otherwise you might cut your finger like I did. Don't be silly like me. I still had some leftover fuel, so I thought I could reuse it, but that turned out to be a bad idea too. Again, don't be silly like me. So I made a fresh batch of fuel, but this time I changed the ratio to 60% potassium nitrate and 40% sugar. It's a fuel-rich mixture, so it will perform slightly less than the 65 to 35 mix, but it should be much easier to pack. So let's give it a try. But before that, I have to clean the pan. And now it's basically like new again. It's time to cook again. Nothing really changed this time, but I added a little more water than before. When the fuel was ready, I directly poured it into the liner, and then I made the core using 2 metal washers and the coring rod. In my old design, the motor had 3 small grains, but this time I'm using just a single long grain. It's much easier than making multiple grains. I'll test this leftover fuel later, but for now let's see how the grain turned out. First, I removed the coring rod, and it came out easily because of the oil. The core actually looks really good. Now, let's remove the washers. I can honestly say that this is the best fuel grain I've ever made. It's just perfect. I can't really see inside of it properly, so you guys tell me if everything looks good or not. What did you see? Is everything okay from the inside? Now, let's put the motor together. First, I placed the grain inside the motor. Then I cut a PVC disc from a PVC sheet and placed it on top of the fuel grain. I could use other materials here too, like plywood or cardboard, but for now I'm using PVC. On top of the PVC disc, I placed a metal washer, and then I closed everything using a similar PVC piece, like the one I used in the nozzle. After that, I marked and drilled 3 holes, and then I applied the clay adhesive on top. As you can see, the clay adhesive came out through the holes, and that's exactly what I did while making the nozzle. I removed the extra clay from the holes, added a little more on top, and with that, the rocket motor was finally fully ready. There's a little problem. While I was trying to burn the leftover fuel, I found out that it was not burning properly. And I had already filled the motor with this fuel. So now I honestly don't know if the motor's going to work or not. If you look carefully, you'll notice that this fuel is using the stick I'm holding as fuel. Whenever I touch the burning stick to the fuel, it starts burning, but it stops as soon as I remove the stick. Well, I think this happened because the leftover fuel was not fully dried, so let's see what's going to happen. The motor was looking way too simple, so I decided to give it a name. Although the ink leaked a little, the motor honestly looks much better now. Finally, the day of testing arrived, so I made some igniters, packed everything in a backpack, and headed toward a lonely location. I made this setup to test the motor, and as you can see, I placed some rocks on the test stand so it wouldn't move around. If you want to know how I made this test stand, then go watch this video. Everything is ready now, and the test stand is connected to the computer, so let's ignite the motor. After a long time of failing and learning, I finally made a working PVC rocket motor. The only data I got from the test was the thrust produced by the motor, and it was around 6,200 grams. I was expecting something between 5 to 10 kilograms of thrust, and it ended up making around 6 kilograms. The combined weight of the rocket and the motor would be around 1.5 kilograms, so I don't think 6 kilograms of thrust would be enough for a really fast flight. I'm going to test another rocket motor, because now I want something closer to 8 to 10 kilograms of thrust. I'll also cut this motor in half to see what happened inside it. If you have any questions, you can talk to me on Instagram or join my Discord server. The links are in the description. And you should definitely subscribe to the channel because I'm going to launch this rocket very soon, and I don't think you want to miss that. That's it for this video, and I hope you learned something new today. See you in the skies.